Hi everyone, in this video I'm going to discuss about pseudorandom probing. So in pseudorandom probing, we use an array of non-identical random numbers. So for example, we have pseudorandom numbers 1, 7, 11, 14, 13, 3, 5, then 6, 10, 15, 12, and then 9. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So 12 pseudo-random numbers. So if you remember in linear probing, so if it's supposed that there was a collision. So in linear probing, we have to look for the next slot, right? So for example, we have H and then H plus 1 and then H plus 2 and so on and so forth until we are able to look for some space to insert our key. Now, in the pseudorandom numbers, we vary here. So instead of this sequential na number that we add to the initial H, what we do is add the pseudorandom number generated instead. So for example, we start with H, and then if in the H we haven't found that number, then we have H plus 1, which is the first pseudorandom number that we have found. Or in that case, the first na element in the array. And then if it's not in H plus 1, then we are going to check in H plus 7. And if it's not in H plus 7 yet, then we go to H plus 11. And then if not in H plus 11, we go to H plus 14. Okay, so we basically add the initial H to the pseudo-random number that we have created. So as you can see, there are no duplicates in our in the array of the pseudo-random numbers that have been generated. Okay, so let us see how we can apply it to the given that we had. These keys 25, 10, 54, 38, and so on and so forth. Okay, so let's create our hash table. So we have our index and then we have our key here. So still we have 13 buckets. So we start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So this is where we are going to put our keys. So let's start with 25. So 25 modulo 13, as we already know, is equal to 12. And since 12 is empty, so we add 25 here. So let me just change the color. Let me repeat that and change the color. Okay, so repeating. So 25 modulo 13 is equal to 12. So since 12 is empty, so we add 25 here, the key 25. And we're done with 25. Now let's go to 10. 10 modulo 13 is equal to 10. So, and 10 is empty, so we add 10. The 10th bucket is empty, so we add the key 10 here. And then we are done with it. Now for 54, 54 modulo 13 is equal to 2. And the bucket 2 is empty, so we add 54 here. And then we have 38. So 38 modulo 13 is equal to 12. It's equal to 12. Now, 38, if we add here in the 12, there will be a collision. So let's try 38 plus 1. So since the first element in the array of the pseudo-random numbers is 1, so 38 plus 1 modulo 13 is just equal to 0. Okay, so we add 38 in the 0th bucket. Okay, we are done with 38. Now, let's look for, we are now okay with 25, 10, 54, 38. Let's go to 36. So 36 modulo 13 is equal to 10. But then if we look at the 10th bucket, it's already occupied. So let's add 36 with the first element in the array, which is 1. So 36 plus 1 modulo 13 is equal to 11. And 11 is empty. So we add 36 in the 11th bucket. Okay, we are done with 36 now. And let's look at 18. 18 modulo 13 is equal to 5. So 5 is empty. Bucket 5 is empty. So we add the key 18 here. Okay, now let's go to 28. So 28 modulo 13 is equal to 2. Okay, so let's look at the second bucket. So the second bucket contains 54. So we cannot put 28 there. So let's add 28 with the first element in the array generated, which is 1. So 28 plus 1 modulo 13 is equal to 3. So bucket 3 is empty, so we can put 28 here, right? Now we have 12. The bucket 12, and the key 12 rather, modulo 13 is equal to 12. And the bucket 12 contains 25, so we cannot put 12 there. So we add 12 with the first element in the array, which is 1. So 12 plus 1 modulo 13 will just give you 0, right? And if we look at the bucket 0, it contains 38. We cannot put it there. So let us try adding 12 plus the second element in our pseudorandom number generated array, which is 7. So that will be 12 plus 7 modulo 13. So that will give you a 6. Okay, 6. Now, we have an empty bucket, which is 6. So we are going to add 12 in here. Okay. Okay. Now we are done with the 12. The key, let's go to 90. So this will be a bit long. So for 90, modulo 13, it is equal to 12. And 12 already contains an element. So let's shift. And then let's try adding 90 plus the first element here in our array, which is 1. 90 plus 1 modulo 13, that is equal to 0. And then 0 already contains 38. Cannot do that anymore. So let's try adding it to the next element, which is 7. So 90 plus 7 modulo 13 is equal to 6. And 6 already contains 12. We can't do that. We can insert 90 there. Now let's try adding 90 to 11, which is the next element in the array. So 90 plus 11 modulo 13 is equal to 10. And if we look at bucket 10, it also contains a key 10. So let's move to another. So 90 plus the next element, which is 14. So modulo 13, that will give you a 0. And if we look at the 0th na bucket, it also contains 38. So no, we cannot add it there. Now, next element in the array is 13. So let's add 90 there. 90 plus 13 modulo 13. So that is equal to 12. So back to 12. So 12 contains 25. We cannot do that. So let's move to the next element in the array, which is 3. So 90 plus 3 modulo 13 is equal to 2. And if we look at 2, it contains 54. We cannot do that as well. We cannot insert 90 there. So let's look at the next element in the array, which is 5. So 90 plus 5 modulo 13 is equal to 4. So if we look at the fourth na bucket, it's empty. So we can finally put 90 in there. Okay, so yay, we have found a space for 90. All right, so we are down to our last key, which is 41. So let's compute for 41. So let's start here. So 41 modulo 13 is equal to 2, but then 2 already contains 54. So let's move on. So 41 plus the first element in the pseudo-random number array, which is 1. So modulo 41 plus 1 modulo 13, that is just 3. I know, sorry, it's 3. And if we look at the third bucket, it already contains 28. So we are going to move on and we are going to add 41 with the next element in the array, which is 7. So 41 plus 7 modulo 13 is equal to 9. So let's look at the ninth bucket. Ninth bucket is empty, so we can put 41 here, right? So now we have the final hash table. So in the 0th na bucket, it's 38. In the second bucket, 54. Third, 28. Fourth bucket is 90. Fifth bucket is 18. Sixth bucket is 12. Ninth bucket is 41. 10th bucket is 10. 11th bucket is 36. And 12th bucket is 25. Right? So that's all for pseudorandom proving.